Sir, is the mock solution discussion session is recorded one which is discussed by the case?
Mock session, I'm not pretty sure whether those were recorded or not because those were taken by T, I guess, right? But
Yeah,
if you want, I
actually,
can give you the
mm,
solution for mock solution. I can just the handwritten solution we can provide you in this session after this session. Okay.
okay.
Sir, already it's uploaded yesterday, sir. In
Oh, it's
lecture, yeah.
okay.
And so
Okay, we'll have a look.
the answer of one question
Where it is
in
uploaded?
Oh, that is in lecture slides.
Okay.
sir, answer of one question in the mock handwritten is incorrect, I think.
Okay.
Maybe we'll discuss that after the session.
Yeah, I'll try to do that. But first, let's go through that 7th and 8th week and yeah. So I'm just so week 7 I told you this canine and dysentery. If somebody has not went through the content, also just go through this now and we'll be in a better position to solve most of the problem from the quiz paper. And from week 8, this is like you are already aware of that naive Bayes there, right? So from this naive Bayes itself and from week 8 you will be getting all the calculation based questions. So all the calculation based questions will be getting. So try to solve all the questions which are in the practice assignment or graded assignment, okay, from this naive Bayes concept, okay. Like you have been given some data set with some probability value and then you need to calculate this. So can you tell me what is this? This what does that mean?
So it is the feature 1 with label 0.
Yeah, and what does that mean? That this is in the label 0. You are taking care of that feature 1, right? But what does that mean? Do you know that how
See,
do you calculate that? How generally you
So it
probability
calculate
that
is
this?
the value will be 0.
so it is number of zeros
Yeah,
divided by the
you
total
go
number
first. You go in the class 0, and then you count all the vectors which are having this one.
all the
Not count.
features.
Yeah. So you generally calculate the fraction, right? So you
Correct.
Sir,
just
f
go
of
in
1
while yeah.
f1 equal to 1 given y equal to 0.
So f1 equals to 1.
Yeah. Given y equal to 0.
Yeah. So you generally go in that basket the where the label is 0, and then you go for you generally count the fraction. Like you generally see in which fraction this feature 1 is available. What is the fraction in which of all in this basket, the other basket where the y label is 0, the fraction generally you see, right? So basically this comes under 0 to 1. The value will be always 0 to 1, right? Okay, so this was the brief idea that I gave you from week 7 and week 8. So week 8 is whole naive base, but mostly if you are just go through and try to solve those problems, and if you're facing some problem, you can just go through the lecture part of this naive base, I guess second or third lectures, and you'll be in a good position to solve this type of problem. Okay, basically the formula you already know, but if you are not, if the whatever has been discussed in the lecture, the denotion part, if you are not able to understand that, then it will be difficult for you to solve. But if you are aware of those, you'll be able to solve. Even it's like not that difficult to solve. Okay, yeah. So leave that, and then we'll start with this week 7
Sir,
ka review.
week 5
Yeah.
is
So week
again.
same for week 5 and week 6 as well.
Okay, week 5 and 6. I guess Ram would have discussed that, right? He would have discussed the whole concept from week 5 and 6.
No, not the concept, sir. Just the topic.
Coach, they are in.
Okay, so first I'll go through this and then only I'll discuss that. Okay.
Sure, sir.
Okay. So in week 7, basically it starts with the basic idea of what is that classification problems and what generally how generally you do that and what are the some algorithm we are discussing, where you are able to classify the classes. If you have a data set, two different types of data set, how will you find that hyperplane, or how will you find that line that will separate those data set? Okay, and basically we are discussing the very basic algorithm. The first one is the KNN, and then the advanced one is like the decision tree that we are discussing here. Okay, so in the classification you have the a basic training data set you'll be having, and then you need to train your algorithm on that data set. But does K- does KNN model learn anything from that data set?
No,
No, no, no.
Correct. So basically what happens in, okay, so first, whenever you have a data set, like for example you have some training data set, and then you have to classify, like let's discuss about the binary only. So mostly we are discussing about the binary classification in whole of our MLT courses. Okay, so in the binary classification you just have two types of classes. Okay, class 1 or class 2, or whatever you want to denote it, maybe -1 1 or 0 1 or anything else also if you want to denote, that is fine. Okay, so you have a data set in the form, and then the label could be in form of 0 1 or -1 or 1, and then you just need a hyperplane that should separate those data set. Okay, and that can be done. So first we have tried with that. However, we were doing in the linear regression. In the linear regression, we are having a very nice what you can say is the loss function, and with that loss function in the linear regression, we were able to do that square loss that we used to study. But here also we are trying to do the same thing, but in the same thing, just we are trying to learn that hyperplane. Okay, and then after that what we are doing, that we are applying some signum function on that, so that so we are just basically applying after getting this, after learning that. So basically we are doing the same steps in the classification. When we started for the binary classification, we are trying to do similar type of stuffs in whatever we have done in the linear regression, and then we are trying to apply a signum function, so that it will, whenever the signum function, the w, like for example we have just learned the weight vector w transpose, and then this w transpose x if we are getting, and if I'm like applying the signum function, it will represent like this. So we are trying to do the same thing that we have done with the linear regression, except we are trying the signum function, signum in the end of whatever we're getting. Okay, and we have tried that, but in the end, what was the reason we are not doing that? What was the reason? What was the problem that we were getting? Anyone of you want to say that?
in KNN, you want.
No, no, not in the KNN. In so linear classifier, when we are trying to do the same things like the way we are doing the linear regression and then applying the signum function, what was the issue that was happening here? So let's, for example, we got this hyperplane, okay, but if we are getting some, if the data sets, if we are adding some outlier or something like that, what happens here? So
Sir,
basic,
No,
yeah.
outlier is the
The outlier is the problem here, because see in this loss function, what was the loss function that, so loss function basically we have this type of loss function here, where generally counts how many of the data points is not been categorized with this hyperplane. So basically this loss function 0 1 loss function, what does this tell? It just tells you the fraction of all those points which are not been categorized nicely, like in the correct way. Like for example, if we have a hyperplane like this, and if we have some, this is a whole half plane where all those class 1 is there, this is class 1 and this is class 0. But you can have, if you have, you generally been in this loss 0 and loss function, you basically adds or sum up all the misclassified classes. Okay, and then you calculate the fraction. Okay, and that you need to minimize basically to get the hyperplane here. But basically if you are, even if you are adding some outlier, or even the data set that is there that is like very, so basically linear regression, what does that, linear regression generally will calculate the error part, but for this loss function it generally counts the number that is misclassified. Even this is an outlier and this is classified correctly, it will not change anything, right? It should not change, because it's like a, what, it's like you should be having a hyperplane that should just classify the both the classes. But if you are doing the approach using the linear regression pattern, then the linear, with the help of linear regression pattern, the weighted value itself will change whenever you are having some outlier or something. Okay, so that's why basically we are not using that approach and we are going with some different algorithm and all, like for example Kane and deviation, because whatever the the loss function that we were using in the linear regression, that was on a different stuff, because there we were trying to calculate the error, but here we just have to calculate the number of misclassified, and because of that we have to calculate the hyperplane. So that was the thing that we didn't use the same concept that we are using in the linear regression. Okay, and that's why we went with the basic approach, and that was the Kane algorithm. And Kane algorithm is what Kane algorithm is the pretty simple one. So if you have been given, so the best part about the Kane is that it's not the best part, like just is that it doesn't uh, basically it didn't, whenever you have been given a data set in the Kane model, it's like very simple algorithm, and it doesn't basically remember anything. It doesn't train any model on your on your data set. It's basically calculate whenever you give a test data set. You have some, for example, a test a training data set of some maybe for 1,000 data set. Okay, so what it will do is whenever you'll give a new data point, and then you will ask the model to tell me from which category or which class this is belonging. What it will do is we'll start calculating the distance, or maybe some other method also it will calculate some, and then with the help of that distance, if your k value, it depends on you what is the value of k you are giving. If you are giving some 5 6, so whatever the number you are giving, it will just calculate from that point the minimum 5 point. If you are giving the k equals to 5, it will calculate the minimum 5 points. Those are very close or in the neighborhood of that point, and then on the basis of majority, it will tell you from this class this is belonging. Okay, let's for example, if you have some okay, so if for example you have, let's for example this is the x test that you are trying to test, and you have some, and the k value was 5 basically, and then you have some two types of classes, and the distance was simply d equals to 1, and then the d equals to 1.1, and then you have three circles. So it will classify this as a, and this was the 5 nearest point to this x test, and on the basis of majority it will tell you this belongs to a circle class. Okay, not the cross part. Okay, so it's like pretty simple, it's not that difficult. Okay, and one thing that can be asked in the paper, like you can see that we have like, it can be, we can calculate the Manhattan or Euclidean distance, so that doesn't matter. Like the basic stuff is it will start and that's the worst part about this is it doesn't learn anything. And whenever you are giving a new data set to predict in which class is belonging, it will start calculating the same thing. If you are applying the Euclidean distance, it will calculate the distance from this x test to each of the point whatever you have. Like for example, if you have 10 points, it will calculate 10 distances from this point, and then if you are applying the value of k, whatever you are applying for some n value, if you are applying, it will calculate the nth neighbor point, and then on the basis of majority, it will classify with which class this is belonging to. Okay, whether you are applying Manhattan distance or Euclidean, anything is fine. So that was the in the KNN neighbor. One more thing, let's for example, if you have some n data points itself, if you have n data points, and if the value of k is equals to n, so what does that, then what will happen? Can somebody tell me? If you have k equals to n itself, then what will happen?
The point
Then
itself
loss,
will be the distance.
yeah, loss will be 0.
No, see, if
And
you have like, yeah, n
each
data points you have,
each
and
point
you are
would be a
taking the,
cluster.
yeah, so in the starting, so what will happen is it will overfit. See, how does it happen? Let's for example, you have some n data point, and you have this x-axis, and you were having some 4 point itself in the starting, and out of that 4 point, let's for example 3 was circle and 1 was cross. And if you are taking k equals to 4, that means what? whatever was the fraction in the starting, it will classify that X test in the same way. Like in the starting, you were having 3 out of 4 belongs to class 0, right? So it will always classify this X test as what? It will always classify this X test as what? Circle, right? Correct?
You're right. Yeah, correct.
Yeah. So whenever, so yeah, so and how will you calculate that value? So how can you calculate the optimum value of k? How generally you calculate with some method you have been discussed, right? So you basically cross validate, or maybe a algo method can also help you to know the correct, or maybe the optimum value of k, right? That will is suitable for your data set. Okay, so that maybe the cross validation or elbow method, any of the stuffs can help you. And you are aware of the hyperplane. What does that hyperplane means? So that, what is that hyperplane?
A plane in greater than third dimension.
No, what does that
Something that is not a part of the algorithm but is passed to the algorithm.
what is that hyperparameter mean? Yeah, so you are correct in one way. So basically the so it's not, yeah, you were totally correct. Like for example in this, so what we are giving from the outside for the KNN algorithm, we need to know regarding the optimum value of some k, and d also we are deciding, right? So I told you 2 examples. So the distance metric can have, like for example Euclidean distance also you can calculate. So it depends on the, say if you have a real number, basically you'll be always using this Euclidean distance. But if you have some different, like for example you're working on a data set of some amino acid or some protein, where your data set will be in the form of some 4 character itself. Okay, so there you'll be using some different metric, right? You can't use the same, you can't calculate the distance if you have some categorical type of data set, right? So there the different types of distance metric will come and will help you, right?
So, in the exam point of view, do we need to use Euclidean distance or Manhattan distance? Which one we should
Yeah,
prefer if it is
yeah,
not
so it
mentioned?
will mention always the Euclidean distance in the paper. Okay.
Okay.
So don't worry about that. So in just telling about the other metric, but in the examination you'll be asked about to, the calculation part won't be there from the KNN model. The KNN you can be asked pretty simple, what you can say, MSQ type of paper, like question, some 4 5 statements will be given, and then out of that 2 or 3 is correct. Okay, so it's like not that difficult, and nothing is there to be read in that this KNN. Okay, it's very easy to implement that. And the disadvantage also that you are not learning any model. So whenever you are giving a new data set, it will calculate again, it will start from the starting, it will calculate whatever the distance metric you are giving, it will calculate the value for each of the data point from that X test, and then it will, based on the majority, it will give you the which class it's belonging to. Okay, and if your k value is very less, then your decision boundary will be like this. It will start over fit. Okay, right, you can see that it will start over, even for one data point it will start categorizing. Okay, and that is not good because it is only working nicely on the training data set. If you'll give the other data or the test data set, it will not work properly, right? So whenever you have k equals to 1 very less, that it will start under fit, right? And whenever you have kn very can you mute yourself? Okay, yeah. So and whenever you have k as very large, what will happen? I told you, it will, whatever the X data set you are giving, it will categorize from the starting itself, right?
When k is large, it is overfitting.
Yeah, the small value of k could lead to, yeah, so this is overfitting.
Sir, small value will underfit or overfit?
It will overfit, right? It is overfitting. See, for each and every data points it is fitting, right?
Okay.
And this will underfit, right? This is underfitting. Why? Because in the starting itself, whatever the proportion of classes was, it will, whatever the X test you are giving any data point, it will start because it. See, if you were having some 100 data points itself and you are giving a k equals to 100, what will it do? It already decided that whatever the data point will come, it will be on the basis of whatever the 100 data set you were having. And out of 100 data set, let's for example 60 was class 1 and 40 was class 0, right? And if you are giving some X data set, X test, it will calculate the distance. Even calculate or not, you are already aware of that. If you have 100 data points itself, it will always classify the data set class 1, right? Because in the starting itself it was fixed, so that's why it is underfit.
Okay.
Yeah, and it is overfitting because the directs for each and every, it is going to check for each and every point, and that is not correct in this algorithm. Okay, so you
So
should be having some
when it
optimal
will
value.
properly fit, like for
Yeah, that you have to
two.
calculate, right?
Okay,
Yeah,
fine.
maybe k equals to 4 5, like depends on how you're doing that. So the method are basically this, that elbow method generally we use to calculate the gain. So for each, so what generally you do, you have that loss function, right? So you calculate the loss function and pick out the k value randomly, okay, and then plot it with the loss function. And for those value, you will be picking out where the kn, this value k is some optimum value and your loss is minimum, right? You'll be getting some plot, right? You can get some plot, okay,
Okay.
and you can just choose out of them k value where you're thinking that, because you can't choose this k value also, because here you are seeing that started overfitting. For this k values, it is underfitting, right? Because this loss function should be minimum, but it's like, see, if you are plotting, let's for example, and this should be clear, right? This, if you are reducing, the statement can be whenever the k value is very less, it started overfitting or underfitting. So don't get confused, because this overfitting for each and every data point, that's why it is overfitting.
So when k
Overfitting
is
size.
1, when k is 1, loss is 0. No.
Yeah, you can say that loss is 0, but it's like not for all the cases. It depends on the data points also, right? See, for this k equals to 1, you can see that the decision boundary for checking each and every circle, the yellow circle, right? And then it is categorizing, correct?
Yeah.
And it is, and here also see, for let's for example this one, the other one, the blue one also, it is categorized. So this is also one of the, like, this here also, this like decision boundary it is fixing, but that is not correct, right? Should not be like this. So that's why, for example, you can just leave that part. If you are not able to categorize it, you can just leave that part. You should not be going for each and every data point if you have a data set like in some billion or billion.
So we can say in this part, like we are assigning the label to the data point which has the most nearest distance to it in overfitting condition.
Can you repeat that?
Means in overfitting condition we can say like this, like we are assigning the label to our data point which has the nearest point to it, means only the nearest point.
Correct, correct. If you have like a one, yeah.
Yeah,
So
and
let's
and
for
for
example,
and for
hmm,
underfitting we can say like we are taking average out of top 100 points.
we can say that. So for a k equals to 1, so just for example, this is the x test. So it will just calculate the, it will just tell you the label of the nearest data set. That's it.
No, in case of k equal to 1, there will be no misclassification, right? Because everything
There won't
is,
be any,
yeah,
yeah, there won't be any. So this is basically on the training data set. So you can say that the loss is also 0.
yeah, for training data set.
Yeah, for training, because it's classifying for each, for separating each of the data point, right?
Yeah.
Okay, because learning on the training, so the loss will be 0, right? It's already
And-
learning. It's like
I mean,
basically memorizing. Yeah.
Is it then fair to say that if k is equal to n, which is number of data points,
Hmm.
then also there will be no misclassification?
No. See, if you have, like, for example, k equals to n, and then let's, for example, this is the plot you can see, right? So if we have k equals to 100, this is the, let's, for example, this is the descent boundary that you have made. So here the because you were having 100 data points itself, and on that basis itself you are classifying anything. So every time, most of the time, you'll be getting the same classes that were there in the starting, right?
Yes.
So that's why this is like not a good idea to get the k very large, and also not a good idea to get k very less. That's why we go for some optimum value, and
No,
there are some.
I understand that. I'm just trying to see. So if I draw a chart, let's say I'm trying to find the optimal value of k. So if on my x-axis I have k, which goes from 1 to infinity, or 1 to the number of data points, and on the y-axis I have loss, right?
Yeah,
Then it
yeah,
will kind of form some kind of a bell curve, right?
yeah.
Okay. I just want to make sure that I understood that.
Okay, so what else is there? Yeah, so Canaan basically, if you have okay, so yeah, so okay, so what you're saying, bell curve, right? Bell curve, I don't think so. It will be bell curve, because bell curve generally is like symmetric about some mean, right? It won't be
I
like
mean,
this.
no, it doesn't need. I mean, it could be a skewed bell curve. It doesn't have to be around the mean, but it will start with 0, right? I mean, 0 at when k equal to 1.
So see,
When k is equal to 1,
this
training error will be 0.
yeah, training error will be 0. That is fine.
Test
Yeah,
error will be
but
high.
Yeah, no, I'm talking of the training for to start
So
with.
it will overfit. So it is a case of overfit. When
Yes.
the k is equal to 100, no, training error itself will be very high. So it is called the underfit, I think. If I am
it
not.
will it will
No,
go
no,
like this.
Okay.
So the loss value will be something like this, and this will be the k that will denote.
Oh.
Maybe I'm mistaken or something. So
Opposite, sir.
I need.
No, if you go just on the top and look at the log,
Zero, no, sir. Training error will be 0 when k is
when k is 1, training error loss is 0.
training error loss is 0.
Yeah.
So
We are not
basically,
doing
it's
the
like,
validation.
yeah. So as it will start increasing the value of k, the loss will increase. See,
Yeah,
and there
but
will
after a certain point, the loss will actually come down again. Because if the number of clusters or is equal to the number of data points, then everything is a cluster in itself. So the distance will become 0 between the point and the cluster. I think that is what the definition says.
so it can whatever, like, see, whenever we used to do that coding and all, see, loss, see, it's like basically here it is k value, but the plot will go like this. See, in the starting, when you will take the value of some k, so it will go something like this, and for some optimum value of k, the loss should be minimum, and then again it will start increasing. So it won't be like this, but it will be something like this, where you'll be having some k optimum, and this will be your loss. So it will be something like this. I need to check it first. Okay, and then I'll let you know.
Okay.
But yeah, for this case, whatever the plot that we have, you can see that on the training data set, the loss was very less for this case and it was very high for this case, right? Whenever, see the decision boundary, you can see that, and here also there's like lot of data point that has been misclassified,
Excuse me,
right?
we are not able to see the mouse movement, so maybe you'll have to use a pointer or something.
Okay, so see, you can see the data points here, right?
Yeah.
And this is the misclassified one, and also this is also the misclassified, right? So if you have more misclassification, the fraction, that value will start increasing, right? Correct?
Yeah.
So you are also in some way you are correct that will at after some point will start again increasing. Okay.
Okay, sir. Sir, please go ahead.
Let's move on.
Okay, so let's come to the decision tree. So if you have any problem in Kenyan, you can just ask, and basically the theoretical problem will be there. And if you are having some calculation based also, you can be given like some 2-3 data points, right? You can be given some 2-3 data points, and then you will ask, and there won't be much. Maximum there can be 4 data points can be given, and then a new data point that you need to classify. Those will be pretty simple, right? You just have to calculate 4 distance, and then on that basis the distance metric itself will be given to you in the exam. Okay, so there won't be any difficulty, I guess, from this portion. Let me check it again. 1 second, just wait for 1 second. Oh, yeah. Okay, so if we have been given this, like K, okay, so I'll just give you some 4 statement regarding K and M. Just tell me how many of them is correct. The first statement is, it's a supervised learning. Okay, this is a supervised learning. Can work on both classification and regression.
Yes, sir.
And the second statement is, the training data set is not required. The third statement is, if K is very less, it will underfit. So how many of the statement is correct? The first one is correct or not?
Just the
Yes.
first one.
Yes, first one. Just first one is correct.
The second one, the training data set is not required.
False.
And is this true for the decision tree?
No, decision tree we don't require training set.
Yeah, so if this was asked for the decision tree, you would have told yes. And if K is very less, it's underfit. So it's
No, but in decision tree, if you don't have data set, then how will it develop the model? How it learns the model?
From test
after training. No.
After training it is not required, but at the initial point you need the training.
Yeah, I was just telling for the training is not required for after learning the model, because in Canaan you are not learning anything, right?
Yeah.
Okay, so let's come to this. Yeah.
Training that the KNN doesn't generate any model. So training data set is required now.
Yeah, so that's why I told you it's not required. So that's why it's incorrect.
Right. Thank
So yeah, so we'll discuss the decision tree, and then so should I discuss the decision tree from the basic, or just the one example, or maybe one problem can suffice that?
Yes, yes, one problem can suffice. I think.
Yeah, I think let's start with the problem, and
Yeah, maybe one
along the
problem
problem,
can
we can
suffice.
talk about the concept.
Yeah.
Okay.
We can try the quiz 2 one. There is one problem is there 13 and 14.
Sir, entropy function, information gain, and something about Gini index. That will suffice, I
Gini
guess.
index is not taught, right? I guess.
Okay, one
But
of the live sessions it was covered, so I thought.
So Gini imperative has not been taught. So basically, you have been taught that information and how to calculate that and that part, the entropy, right? So let's, for
Okay.
example, have a simple example that I am giving you. So you have some. So in the starting, you were having something, and you have some class 1 and class 0. So class 1 value was 16, and this is some feature 1. And the class 0 is 14. Okay, and then this is some question q1, and then on that basis, if this is some y, then it comes here, and here the class 1 will be what, 12, and class 0 is 1, and here for no it is what, the class 1 is 4 and class 0 is 13. Okay, so can you calculate the information gain for this case? Can you calculate that? Let's first calculate the entropy for this parent P, and then calculate for this left side, and then calculate for this right side. Okay. So the basic formula for this EP is what? How do we calculate that?
Minus of P log P plus 1 minus
Yeah,
P log 1 minus P.
correct. So you will check it. So 16 upon 30 log, and this base should be 2, right?
Sir, can
This
I
6.
conduct the basic formula again?
You want to know the basic formula? This is what you are asking.
Yes, sir.
See, basically you calculate. See, entropy itself is like minus P log P, and this base is 2. Okay, and how do you calculate this probability of this? Yes, how do you calculate this? The 16 upon 30, right? From here,
Yes.
right? So similarly, you'll do for all the stuff. So EP you have calculated like this, minus, and the same thing you'll do for this, the 0. For the class 1 you have done, and then the same thing you'll do for the class 0 also. Correct? So it will be like minus, this was for the class 1, and then you will do
Into
for the class
14 by
0.
30.
This is minus 14 by 30 log of 2, 14 by 30. Okay, and whenever you are calculating, calculate. So you have to calculate it. So know how to use that in the TCS exam, that log, how do you calculate the value of log? Okay, and that you have to calculate. So you'll get some value. Okay, and how will you calculate for this EL? EL also. So can somebody tell me the value, exact value what you will be getting here?
Minus 12 by
Minus
that.
12 by 13, sir.
Yeah, minus 12 by 13
No,
log of 2, 12 by 13, and then
minus
minus the
1
same
by
thing,
13.
1 by 13 log 2, 1 by 13. Okay, so you'll be getting some value here. Okay, so I have a value, so I can directly write it down, 0.99, and this is 0.39. Similarly, if you will do for this E right, the same thing you'll be doing, right? Same thing you'll be doing, you'll get some value. Let's, for example, you're getting this one. So how will you calculate the information gain? What should be the value of information gain? I told you
Right?
this is EP
And
minus
entropy of
minus
parent
weighted.
minus weight of left multiply entropy of left
this is what
plus.
you're calculating, right?
So, sir,
And
it
how
should be
will it,
zero.
What?
Information
what will
gain.
be information gain? It won't be zero, right? For this case.
Uh,
And how will can you please mute yourself, like the one who is. Yeah. And let's, for example, you have calculated the information gain for the first case, the first feature. And similarly, you have been, see, basically you can be given two features. So feature one was given, and the same way, so on this feature, so basically what we generally do in the decision tree, we start asking the question and we have to check for which is the, in which cases the, you are getting the very less randomness, and then you choose that feature as a splitter for the first case, for the first node, right? So if you are given the feature 1 and similarly you have been given the feature 2, on that feature 2 also you can be given some, this is the feature 2 ka questions, and then on that basis you are splitting on that, in this basis, let's for example you have this class 1 as 16 and then 0 was 14, but here, and you, here you are splitting on the, let's for example this, the feature 1, basically the feature 1 you were having categorical value, and that categorical value was 2. Maybe for feature 2 it can have the 3 categorical value. Okay, and how will you calculate? So EP you will be calculating. Okay, so EP will be whether it will be same or different for the, from the first feature.
It may be different. It may be different.
But for this case I am telling, the class 1 is 16, the same you are getting, the class you are getting same, right? So EP will be same as the other one. And let's for example here it is 1 equals to 7, 0 equals to, so basically you are getting some random value. Okay, and if you have to calculate the information gain for this case, how will you calculate that?
EP minus
All three and first left, then this left, and then
Basically you have to do, see, you have to subtract that from this, you have to do the addition, this whatever E1, E2, E3, correct, the weighted one, and then you need to
Can you
do.
solve
And
one question first? Like this, so it's not complicated.
okay, should I solve for the feature 1?
Anyone, sir. This information gained part only. Like
Okay.
the entropy part is completed.
Yeah, actually, we are having a lot of confusion in gamma also.
Okay. So okay, then I'll discuss this the ways that. So yeah, this week 7, right? Okay. Let's come to this one. So this was entropy, that okay. Entropy part. Okay, and then how do we calculate the information gain? You just have to calculate the entropy for D, and then you have to calculate the entropy for DS, and then the entropy of D no. Okay, and this gamma is what? Gamma is DS upon D. So D is the total number of data set that we were having. Okay. So let's for example, if here there's no problem that is installed here. Okay. So in the mock, is there any question from the decision tree or? It's okay. Wait for 1 minute. I'll just take one question if you have any question.
There is a mock. There is a.
Sure, sir.
There are two questions are there. One is on decision tree, another is on this information gain. Both we can solve.
Okay. Okay. Let's. I'll just open that. Wait for a minute. let's discuss for this case itself. You were having, so you are calculated the value of EP, the parent one, okay, and then you have this one. So okay, let me tell me the what will be the gamma value for this D. Let's for example this is DS and this is D no. What will be the gamma value for this? Tell me. So number of data set that have came to DS. Okay, so this will be 30
13
the
by
per
30. 13 by
13
30
by
and
30,
17.
and this will be 17 by 30. Okay, so this is the weighted value of DS and this is the weighted value of D no. And if you have to calculate the information gain for this first EG1, what will you do? So basically you have the exact value. What was the exact value of EP? EP I have calculated, this is 0.99. This is 0.99 minus of what is the gamma value? 13 upon what was that? 30 into EL is what? EL the value is 0.39 plus 17 upon 30 into 0.79. So this is how you will calculate the E1, EZ1. So this is basically whatever the value you are getting. Let's for example you are getting some 0.99 minus, you will be getting what? You will be getting some values like 13 into 0.3, and then this is okay. I'll just do the calculation with the calculator. We'll get some value, okay, some exact value, and that is like 0.65. Okay, so you are getting some 0.39. Okay, so this is the information gain for the first feature, correct? Okay, is this clear to you?
Ah, yes, okay, it's okay, it's okay.
Yeah,
Yes,
so
sir.
this is how you generally calculate. Let's for example, and if you have been given two features and then you have been asked in which features it will start splitting. Okay, so for your first feature you have calculated, right? So for first feature you got some like you got some information gain. So you got the information gain IG1 equals to 0.39, and you have got the information gain for second cases is what? Let's for example for the second splitter, when we were asking for the feature 2, you got some this information gain 2 as something like 0.13. So tell me on which splitter it will, on which feature it will start splitting. So for
Whichever has
first
that.
case
First one.
you were having 0.39, so on which splitter? This is for feature 1 and this is for feature 2. So it will start splitting for this question. Which feature? F1
Feature
or
one,
F2?
feature.
Feature 1.
Why 1?
One,
Why?
because information gain is more, sir. The
Yeah,
amount of
information.
information that we get is more.
Correct. So it start from some starting point. Information gain is more means what? In the later part, the the entropy was less, right? That's why the difference is high. So we are gaining something more. So that's why we will go with then from wherever the information gain is more, right? Or the purity is like increasing, or you can say the impurity is decreasing. Correct? Because see, in the first case you were having some entropy. In the second is basically you are doing EP minus some weighted average of this one. So if this was less, then only you were having this information gain and information gain more. This this entropy is less means the randomness is less. Randomness less is impurity is less means purity is more, right? So that's why in the second part when we were splitting, we were getting a more pure data point. So that's why we are going with F1, right? Not with F2. Correct? Is this clear to everyone?
Ah,
So will
yeah,
you
yeah,
be
yeah,
able
yeah,
to
yeah.
will you be
Yes.
able to solve the problem, right, in the paper? So if you are getting this time to where you have to calculate the entropy, so this is the formula that should be applying. And remember, this gamma is the number of the data points that are there in the left part, okay, and that divided with the number of total number of data points, okay, and then you can do 1 minus gamma. If you have two like categorical value only, if you have like 3, then you should be calculating for each of the cases. Like for example for this case you were having for F2 you were having 3 values, right? And in this 3 value, let's for example you have some 7 1 4 6, and the starting it was same, the class 1 was 16, class 0 was 14, and you have some 5 7. So what would be the gamma value for this case?
8 by 13.
Yeah, so 8 by, so whatever the 13.
13. 10 by 30 and 12 by 30.
Correct. So similarly, you will do for 10 by 30 and this for 12 by 30. Right? So this is the gamma value for each of the cases. Okay. So now you'll be
Then
able to calculate.
summations where we require to use 1 minus gamma then.
So
Have two
see, if you
variables and we have two classes.
yeah, when you have two categorical value for the feature 2, then you will be doing this gamma and 1 minus gamma. But if you have 3, then you can directly calculate. So this is, let's for example, this is gamma 1, this is gamma 2, then this will be 1 minus gamma 1 minus gamma 2. Okay, is this clear?
Yeah, clear, sir.
Okay, so if you have any doubt, you can just ask me for the decision tree, right? And for the decision tree, the statement based question can also come for this source.
If you can go through the decision boundaries of this. Actually,
Okay.
Suppose we are in 2 dimension, then how many questions are required to generate a rectangular type of things?
Okay, let's come here.
Sir, for three decisions, could you write that formula for information gain?
Okay, so see, let's for example, you have some, so I'll just solve this. You have a feature.
In feature 2, we have 3 roots. Right?
So you have some feature 2, you have the class, let's put 16, class 1 and class 0 is 14. Okay, and then you have 3 category. Let's, for example, this is class 1 is 7, 4, 6, this was 5, 7. Okay, and if you have to calculate the value, how will you calculate? Basically, EP, the information gain of 2 will be this EP value. So EP you can calculate directly, and EP we are getting 0.99 minus of this, let's for example, this is E1, E2 and E3, and the gamma is what? 8 upon 30 times E1 plus 10 upon 30 times E2 plus 12 upon 30 times E3. Okay, and then you can calculate, right? E1, E2, E3 you can calculate directly. It's literally the entropy you can calculate that. Okay,
Right,
yeah,
sir.
entropy, yeah, this 7 upon 8 minus of logs 2, 7 upon 8. Similarly for this one cases also, so we'll be able to do. I don't think so there will be any problem in this.
Sir, what we can conclude if IG1 is greater than IG2?
Yeah, if IG1 is greater than IG2, that means you should start from IG, that first feature. Okay, so that whatever the first question was there, on whatever basis you have split it, okay, so that should be your starting point. You should split from there because you are getting more pure values, right?
Okay, sir.
Yeah, so that should be there. And here also, what are the hyperparameters for this decision tree? What are the hyperparameters for this decision tree?
Depth.
Yeah, so depth, and that depth, if we have, let's for example, if you started increasing the depth, okay, what will happen?
Overfitting.
Can someone, so it is
Overfitting, sir.
yeah, correct. And if we are in the starting, in the only one case, if you are putting very less, the depth is very less, then what will happen? See, what generally happens if the maximum depth is too high now, what will it will do? It will start in just memorizing the training data set, right? Correct?
Yeah.
So okay, again I'm giving you some force statement for the decision tree. Tell me
So
whether
how do you determine the optimal depth?
so this is also again the hyperparameter, right? So again the same thing we'll be doing. We'll be calculating the same things, loss versus this value, depth ka value, and then some optimum value you'll be choosing on the basis of loss value.
Okay, thank you.
Sir, as depth is very less or depth decreases, it will overfit only, no, sir?
Yeah, yes, I'm
Okay.
just discussing it.
Okay. Sir.
So in the decision tree, training data is required after getting the model. If depth is too shallow, then overfit. If okay, so out of 3 statements, how many of these are correct? The first statement is in decision tree you are needing this training data set is required after getting the model. Is
Incorrect.
First
this
one is
correct?
incorrect, sir.
Incorrect, sir.
So anyone is having any issue, this is incorrect, right? The second statement is if your depth of this tree is too shallow, then it will start overfitting.
It will
Incorrect.
underfit, sir.
Incorrect. Incorrect.
Incorrect or correct?
Incorrect.
Incorrect. Incorrect.
Sir, because the tree which we have grown is too shallow, so we have not extracted the entire information. So still there is room for us, so we can train it further. So we are underfitting.
Okay, so this statement see if you are making okay, if you have a decision tree and you started increasing the depth, so for each and everything it will start making a decision, right? Let's for example you started with some q1 and then you are going down and down. So for each and everything, for a small thing, it will start making a decision. Okay, and if it will start making a decision for each and everything, it's not underfitting.
Overfitting.
Basically, it is overfitting. See, overfitting is what I told you, right? So for in the Canaan, what was happening? For each and every data point, it was giving a decision. Like it for each and every data point, it was the curve was very. See, for example, you have this type of data set, and even if you have some crosshairs, so it will make a decision like it will give you a curve like this also for this one. That should not happen, right? Basically, this is overfitting. Overfitting means for each and every cases, this you are getting a decision in the training data set. That should not happen. That is basically overfitting. This is not underfitting. Underfitting is what from the starting itself, like the graph was like underfitting is totally opposite concept that is under like the overfitting, right? So here also if you have a decision tree and if you have a lot of this depth is very high means it's asking each and every small change it is giving a decision, right? For each and every cases you have something, right? Like for example it started with something and for each and like for example the feature value f1 was some theta 1
Sir, I think
and then
graph is the exact example the previously you showed in the starting of the class. Two examples of overfitting and underfitting.
So that was for the Canaan. Let me check whether I have for the decision tree or not.
So overfitting data won't perform good on test data, right?
No, none of the two will do perform better, man. Even whether it's underfit or overfit. See, overfit is what in the training. Overfitting is basically you just memorized all the data points. Let's, for example, there's a data that is overfit. That means you were having some feature, 3 feature, and on that basis you were having the label. So you just memorize. So the way a student or anyone is memorizing. So we were having some 1000 data point. For each of the data point, just memorize the label, right? So that is basically it's a. But if you are giving some other test data set and that is not from the training, it will give you wrong, right? The label, because you just memorize for the training data set, just overfit on that itself. So that's why it is making sense to you or not.
Yes, sir.
See, I'm just going with the same
Yes.
example again. You can see that here whenever you were having this Knn wala example, for each and every data point you were taking into consideration. That you should not be doing while doing the algorithm, right? There can be some mistakes, that is totally fine. So see, the graph that is plotted here, the decision boundary that you can see in the purple color, this green color, this is one of the best, right? Correct?
Yes, sir.
Yeah, but this is also not correct, the red one, and even this is also not correct, right?
Yes.
But the green one is overfitting, right?
It's not going to do that. It depends. You can't say.
It's totally depend on the data set. See, for this example, see, I'm just this type of problem. Like I'm just telling you, there won't be anything in the exam, but I'm just telling you just to get the idea for Knn. If when you are increasing the k value and then decreasing, and for the decision tree also the depth is increased. Okay, so what generally should happen? So you should not think of small changes. If you're just thinking of very large changes, let's for example you are increasing the height as very high. If you are increasing the height of that tree as very high, that means what you are starting from some feature one and asking the question until if and else statement. Decision tree is what you are just putting if and else statement, okay, every time. And if you are putting in the if and else statement so many number of times, that means for each value you are taking into consideration. That you should not be doing, right? If that was the case, why will every time whenever you will doing the decision tree, you should be getting the purity as 100%, right? If you are getting the purity as 100%, that means what? Like you are just memorizing the data set, that's it. So you are not building any model, okay? And in those cases, you are just overfitting everything.
Yes, sir. Which is not necessary. That is overfitting.
Yeah. So is this make now? Are you clear with that? The first statement that I told you, that is why this is incorrect. The second statement, if this is true, this is correct. Sorry, it's not incorrect. It's true. If your depth is too shallow, then it will start overfitting. Because for each and every cases, it's seeing the data. For each and every, like there are a lot of questions if you are applying if and else statement, and then your decision boundary for each and every data points, it is giving you a decision boundary. That should not happen. There can be some mistake that can do, right? That is totally fine, because that build, if you are able to build that type of model, like if you are, you should be getting some loss value. That is totally fine. Not be approach for zero. If you are going approaching for zero, that means you are just memorizing all the stuff, the data set with the label. That's it on the training data set. It will not work on the test data set. So your whatever the loss will be very bad for the test data set if your data is overfitted. Yeah, go ahead.
Sir, the too shallow means of little depth, right?
No, okay. So just remove this.
That was the
Oh, okay, okay.
Exactly. Yeah, that's what I am
Yeah,
going to
yeah.
ask.
See, shallow is
Shall
the thing which is not related thing, right? Too shallow means the data which is not at all related to the point.
shallow means it's actually very small
shallow
depth.
means less,
Small depth.
less
Less
Shallow,
depth.
shallow is the opposite of deep.
Correct.
Okay,
Yeah,
so
that's where I got confused. Yeah.
Yeah.
okay, that's
Shallow
why
is like
there's
hollow.
okay. Whatever the third statement, if you made some small change in the data set, then the decision boundary will change.
Yes, sir.
True.
That's true, right?
Yeah.
Okay. So what I told you in the decision tree, that problem you should be practicing. Maybe you can just get problem if you have any problem, just practice that. I solved one problem and that is good enough to solve any problem. Like you'll be just asked how you should be knowing how what is that gamma value and what is the formula of that information you can add. That's it. If you have been given two features and the numbers should be very less so that you'll be calculating quickly. You just have to split it on which, like you can have a MCQ type of problem where two features can be given, the splitted part can be given, and then you'll be asked on which splitter will start splitting, maybe for feature 1 or feature 2. For those cases you will be calculating the information gain for both the cases and then see for which case is high or wherever uh, the entropy is declining more, and then you can directly say okay.
Sir, will there be tree question with many deep tree, sir?
No, there won't be anything like maximum one, like start with one and this will be the leaf. There won't be any question that is more than the height will be more than 2. Okay.
Actually,
Guess this.
there was
Yeah.
one question. Okay, if we have two features, and then how many questions are asked, how many nodes are required to create a rectangular type of decision boundary?
Where is that question?
I think it was somewhere in
Activity
practice,
question.
activity or practice assignment
Yes,
like
sir.
that.
Okay, let me open that.
Yeah, every question divided into two parts. No? There was some
No, not every
mistake
question.
in the
Some
problem.
questions can be. 1 second.
Sir,
Yeah. So I don't have a
sir,
laptop, that's why I'm just going to check. Yeah. Yeah, go ahead. You're able to.
yes, sir. Sir, there's a question from practice assignment week 7. Shall I read that question? Like we have a tree.
Okay.
Like we have a tree, and it's given that is the form of
Practice
x less
assignment
than.
question number.
Can you share the screen?
Question number 7. Oh, may I share the screen?
Yeah, practice assignment question number. What did you say?
Practice question number 6, sir.
Okay, let me check that.
Question practice assignment 7, question number 6.
Okay, what's the issue here?
So can you solve this? Actually, I don't know how it's happening. Like
So
how
please
we
share.
got.
Let us share your screen.
May I, sir?
Yeah, you can say.
Can you see, sir? This one.
Okay.
Hello.
Yeah, I can't see your screen.
Sir?
Okay. Yeah, now I can see your screen. So you have been given some data point, right? And then you have been asked, you have been given some. Go like up. Just let me read the question from starting.
Show the data points. Hello.
Yeah, can you scroll up?
Hello.
Yeah, can you scroll up? Can you scroll up? Can you?
I think the screen is frozen.
Okay, maybe I can share the same question.
So see, basically, what was that question? The following decision tree cleanly separates two classes such that. Okay, this is the
Wait,
question.
Sir, you
I'll
can
try to,
refer the chat box for the data points.
I'll try
Okay,
to
okay.
share the screen. Maybe you can see.
So this is the data point that has been given, and you have been told that this cleanly separates two classes. So if it is cleanly separates the two classes, your data points are where? So class 1 is from 0 to. Okay, let me write it down somewhere. You are able to see my screen or not?
Yes, sir.
Okay. So okay, tell me the data points that x y was given, right? In this x
X
y
is XY is 21, 10, 0,
10 0
8, 0,
8 0.
minus 4, 1,
The other one is minus 4 1.
minus 4 and 1,
Hmm.
0 and 1, 9 and 0.
Okay, and this is cleanly separates, right?
There are 6 data points. Can you
Cleanly
share your
separate.
screen?
You're not able to see my screen or what?
No, sir,
No,
your
no,
screen
no.
is not visible.
Okay, sorry. This is the data set, right?
Yes, sir.
Let's, for example, you have something, you have this point, and then where are the classes? The class 1 is this is 0, this is 2, this is minus 4. Okay, and where the class 0 are? The class 0 starts with 8, and then you have 9, and then 10. Okay. And what is been asked here? What was that question that you are
The following
splitting?
decision tree cleanly separates the two classes such that the resulting leaves are pure, and then there was a diagram which separates to yes
Okay,
1, no is
okay,
0.
correct. So if you, let's for example, you are starting with some figure theta, okay, and then you are splitting cleanly. So this 3 should come here, this minus 4 0 2 should come here, and this 8 9 10 should come here, right? So what are the theta you can put it here? Theta can be what? Theta can be what? Tell me. It can be, if you are putting theta equals to 3, should it split in cleanly? If you are putting f1 less than 3, it will go, right? This will go. Okay, so 3 can work.
4 to 8.
Can 4 work? Can 4 work?
Yes. Yes. Can
3,
work.
4 can. Similarly, 5 can also work. 3 can work, 4 can work, 5 can work, 6 can work, 7 can work, right? 5, 6, 7 can work. And if you're putting f1 equals less than 8, will this work? Yeah, this will also work, right? Okay. So you should be having six values to that can split this in cleanly. You can't put more than 8, right? If this was less than equals to, then you should be having, I guess, again you should be having 3, like it will start with 2. If we are having f less than, yeah, go ahead.
It could be more than 2 also, sir, on question.
But you told starts with f1 less than some theta, right?
Yes.
The question was what something f1 starts with some less than theta, right?
Yeah, x is like q1 is of the form x less than v. How many possible integer value can we take?
Yeah, and then you have to ask the possible integer for theta, right? This was the exact question. Okay.
So basically, what is theta?
The theta is some random integer value, right? Let's see. So you start whenever you split the in the decision tree, you start with some questions, right? Question 1. And if this is following, if this is yes, this will be the data set, and these are the data set that is following yes, and this will be yes, no. So for this data point, I have plotted on the x-axis. Let's, for example, this was the x-axis, and you can see that this was, you can see that this can be a one line that will separate this class 1 and class 0, correct? And if this line f1 is less than, I told you 3, then it will, if I'm putting the first question itself, the feature 1 is less than 3. If I'm putting this, is this separating all my data point? Yeah, correct. If I'm putting f1 less than 3, f1 less than 3 is minus 4 is less than 3, right? Similarly, 0 is less than 3 and 2 is also less than 3. So that's why it is coming. So minus 4, 0, 2 is coming on the left side. And you can
Yes, I got the
know,
point.
you already know that this is a class 1 class. So it is splitting. So if you'll this is pure, what you can say, this is totally pure, right?
Yes, I got the point. Thank you.
Yeah. Okay, so if you have anything from the decision tree, you can ask, but mostly you'll be getting this type of problem only, the where you have to calculate something. So maybe the information gain, entropy, or anything. Okay, so you'll be getting this type of problem in exam. So be aware of with that and try to solve some problem. Okay.
So here, why is label, sir?
Is this clear to every? What? You're not able to listen me.
So in this question, yes. So here, why is label, sir?
What?
Yes, why is
Label?
the label? Oh, actually, he was asking that why is the label not.
Yeah, why is the
Yeah,
label,
this one.
right?
What? Yeah, 101 is success S. 10
Yeah,
A.
if your data point is 2, then label this is classifying that as a class 1. If your data point is 10, it is classifying as 0.
Okay.
For 8, all the other points, yeah.
In question they asked yes, no. S is 1 and no is 0.
Yeah, see,
So quick
this
question.
feature, if this feature, this one, the value is less than 3, is this less than 3? Yes. So this should go on left side. If this is not less than 3, then this should go on right side. Okay?
Yes, got it.
Yes, sir.
Like anything can happen. See, if this is, so you can write it no here also, yes here also, that doesn't make any difference. You're just splitting those, right? That's why we have entropy in like some symmetrical about some value, right? Okay.
Yes, sir. Here they are asking x less than v.
Yeah, x less than v, right? So this
Yes,
is
how
what
many
I'm
values
saying.
we can take?
So see x less than so this is what x less than 3 can happen, x less than 4 can happen, 5 can happen, 6 can happen, 7 can happen, 8 can happen, right?
-4.
So if I'm putting x less than -4, this is not cleanly puring, right? Your data points will be what?
Yes.
This is yes and this is no. X less than -4 is, do you have any data? No, right? So this
No.
you have 0 data. But here you are getting all the 6 data. Out of this 6 data, you have 3 as class 1 and 3 as class 0. This is not pure data point, right? This is not pure.
Okay, yeah,
Pure
yeah.
means what? It's written like what it was written that in the question, right? It should cleanly separate. Cleanly separate means you should be getting some pure class label. And here you are getting some pure label, right? That's why we are putting 3, 4, 5, 6 till 8. Otherwise you would have kept like x less than 9 also. But this here this is not cleanly separating the data. For this we are getting some 4 data this side, 2 data this side. But this is not clean, right? Out of this 4, one is 3 is from class 1 and the one other one is a class the different class, right? So that's why x less than 9 is not included, because it is including this point also, and that is getting categorized with this 3 point, and this is not pure. That's why we are not including that value.
Okay, sir.
Okay.
Yes.
Any other problem from your practice assignment or graded assignment? So just solve if
Ninth
you
one.
have any problem. Okay.
Sir, should
So
we
ninth
expect
one,
this type of question?
you can't skip. You can't skip this type
No,
of
we can.
problem.
No, expect.
Yeah. You should be. I told you in the starting itself. You will be getting from the decision tree. You have questions where you have to calculate information again, or entropy, or something. That calculative part will be there. And okay, this much hint I am giving you. Just go and practice some problem. Okay, from this decision tree.
Just
Yeah.
So
If you have
ninth
any,
question
so ninth question, you have to tell me
and 8
so
also, sir.
what are the values and the because. Okay, let me open my laptop. Then only I can. Okay, so ninth one. Okay, share. Can some of you can share the
Yeah,
screen and
sure, sir. I'll
let me
share.
know.
I'll share.
Okay, so I'll just stop my sharing the share.
So my screen is visible, right?
Yeah, your screen is visible.
Ninth one, huh?
Yeah,
Or
this
seventh,
one.
eighth? Which one?
Ninth one. Yes.
Yeah.
Okay, just give me one. Okay, so consider the following decision tree for a classification problem in which all the data points and constant to lie in the unit square in the first quadrant. Okay. Okay. Then the first question is, if xr is less than 0.5, yes and no, then if this is no, then you are getting the classification as 1, and then next two. Okay, that is fine. Okay. Okay, then let's build the. Okay, you can. I'll just share my screen. Whether two people can share, right? Screen. Okay, I'll just write it this values and then I'll ask you to stop this. Okay, so
Sure.
this. Okay, I made that decision boundary. Let's go down. Go down. What has been asked? If a point is picked at random from the unit square, what is the probability the decision tree predict that this? Okay, you just have to calculate the area of 1 upon total area, right? Okay. Okay, let me set my screen now. Okay, So the boundary was something like this. The first case was, it starts with x1 less than 0.5, and then it, so this is 0.5.
x2 greater than 0.5.
This is yes, no, right? And this was what, x2 greater than 0.5. This again yes, no was there.
Yes, was
No,
0.
no, greater than 0.25.
25.
No, no, no,
X2
no.
is greater than
0.5 only.
0.2.
It's 0.5 only.
Greater than 0.5, right?
Yeah.
Okay, and then you have yes, no, and this classification was there. Okay. So, and you were having all the data points inside from 0
No,
to 1,
wait.
right?
How can this be correct? If x1 is less than 0.5, and you're saying yes, it is less than 0.5. I mean,
This is
you already
x2,
have.
right? This is x2. This is x2, other feature.
Okay, the other
You
feature.
have x1. Yeah, this is x2. This is x2. This is x1. This is one feature. This is other feature. This is the x1 value. This is x2 value.
Got it.
Okay. The first case was x1 less than 0.5, and if x1 is greater than 0.5, that is already been classified as something, right? From 0 to 1, it's already classified. So this you can classify. For example, this is 1. This is already classified, okay, as label 1. Correct?
Yes.
Is it correct or not? Because
Yes,
see,
Yes.
yes.
and
X2 is
again we are going deeper. X2 greater than 0.5. So x2, let's for example, this is 0.5, and x2 is greater than this one. This area is classified as something, right? So let's for example, this area is what, if x2 is greater than 0.5. If yes, then this is 0, and if no, this is 1. This is 1. Correct? And now we have been asked to calculate, if you will calculate this area is what, 0.25%, and this is 0.75, like sorry, 25%, and this is 75%. Okay.
Yeah, so the probability is 0.75.
Correct. If you are putting any point, if you are taking from this, it will predict, there's a 75% chance that will predict a value like class 1, and 25% that chances it will predict.
Sir, can you again explain how it is exactly 75%?
See, if I'm taking, see, there's a coin. Let's for example, this is a coin, okay, and coin is having the class. So at this head, let's for example, this head is class 1, okay, and if I'm just putting any value, what is the chance that will fall under this class 1? Okay, what can be the chance? The area under 1
Yes.
upon area, whole area, right? Total area. The whole area, whatever is the, let's for example, this is 1 unit, so 1 into 1, and that area will be 75% of that, right? You can see that is a 4 square, and out of this 4 square, 3 square is under 1, right? Correct?
Okay, sir.
So my question is like, what if there are more than two variables, two features? This area.
We have to study that.
So the
So if you
decision
have
boundary
more,
won't be rectangle, and calculation will be very difficult.
yeah, the calculation will be difficult. So it will be
Three-dimensional.
rectangle. Yeah, but okay, you are asking the three features, huh?
Yes,
Okay,
yes.
then it will go beyond, like, won't be that again you have to take care of these three features. So pakka it will not be a rectangle, right?
Now my question is, I could get this visually, but how to do it mathematically?
I think it is done
What would,
mathematically.
it can be done? See, what you have to do basically, you have to you are aware of that. What do you say? What is that name? Even if you have three features, what you have to exactly calculate? Tell me then.
The probability.
Volume you have to calculate.
Volume, right? Yes.
Yeah, then you have to calculate the volume, right?
And it makes.
You can use conditional probability to compute this.
That's my question. Is there a mathematical way to solve this?
Yeah,
That also you can use, but it's like, see, if you have, I don't think so anybody is going to ask you 3 features, 4 features, because you can do it like with the PC, right? Right, like basically just to know whether you have understood, somebody can ask you in the 2 feature, 3 feature, 4 feature, again it will get complex, and then it's very difficult to visualize that also,
So
right?
let's go to next week, sir.
Okay. So shall we move to the next week?
Next week.
Yes,
sir. Yes, sir.
Yes,
It
sir.
is
Yes, sir.
already 2 hours.
Okay, so
And
next
So,
week I'll just
sir,
discuss some problem, and that
practice
goes.
assignment
Yeah.
10. Once, can you
Practice
explain?
assignment.
10. It's very simple,
Sir,
but
sir, I'm having 2 doubts in week 8 graded assignment.
Okay, I'll start. Can we start with week 8?
Yeah.
So
Please,
week
yeah.
7, whoever you have doubt,
Sure,
just
sir.
ask me after this session. Also, you can ask me. So you can just mail me. I just reply to this mail every time. Sal@study.
I think, sir, with question we can do everything.
Yeah. So week
Let us-
8, I'll just start with the questions only. I'll
Yeah.
not go
Please.
So this mail ID, you can just write it any time today. Okay, because you have a tomorrow exam, right? So week 8. So I'll just take the week 8 ka questions itself. Okay, let me open my laptop and then. So yeah, everybody has solved week 8 ka graded and practice, right?
No, sir.
Yes, we just solved
If you haven't solved, it'll be good if you are solving. If you just solve practice and graded, I think so you'll be able to solve the problems from the quiz also. Okay, so it's better go and solve all the problems of graded and assignment. Graded assignment and practice assignment will help you a lot. Okay.
For all weeks, it will help.
7, 8 will help. I haven't went through the 5th and 6th week questions, so I can tell you for that. Even it will help for 5 and 6. See, if you are solving previous term ka paper and this practice and graded, I'm telling you, you will be in the position to solve at least 80 to 90% of the problem. Okay, for any, what you can say, elective, any subject you can say. If you are solving graded and practice and previous term, at least 2 term paper, you are in a position to solve 90% of the problem. Maybe 1 or 2 question it will be difficult, or maybe the conceptually it will be very strong, but most of the paper generally similar concept will come on the similar concept. Okay, so it's better to solve this. See, why did I say for the 8th week? Because 8th week mostly this naive concept is there, and naive concept, what if the question has been discussed, similar question can be asked, because that has been taught in the lectures, right? So that's why I'm telling you, if you are able to solve those questions, you will be in a good position to solve any problem in the exam also. Okay. Yeah. Now tell me the practice assignment, which question you want to discuss for this.
Sir, graded one.
Practice you were saying, right? The week 8.
No, sir, I was asking about graded question number 5th and 8th.
5th and 8th. Okay. So we'll discuss with that itself all the things. Okay. I'm also going through this. Okay. Yeah. First, 6th and 7th you were able to solve, right? Everybody was able to solve the question 6th and 7th.
So before that, can you take questions from practice assignment?
See, anything is fine. Just we'll discuss 2-3 questions, okay, and that will help you to solve any type of problem from this week. Because more or less the question is repetitive, okay.
So you are asking graded assignment question number 6?
Yeah, somebody was asking, right?
Sir, can you take practice assignment question number 3?
Okay, let's discuss that first. Okay, yeah. So question number 3, 4, 5, right? And this is the standard question that we should be knowing how to solve. If you are able to solve even this question, you will be solving the problems, similar problems, even if you are able to solve this. Okay, so I'll just write it. I have a question now. This is the question number.
Yes, sir. 3, 4, 5.
Okay, so I'll just discuss this. You have been given a data matrix, and this is been given 1 0 1 1, sorry 1 1 0 0, and the label. Okay, tell me how many this dimension. This consists of how many dimension? How many data set is there in this matrix?
Three.
Three data.
Yeah. So this is the first data. This is the second data, and this is the third data, right? And what is the label? Label is given 1 1 0, right? Okay, let's. Okay, so it was given. It's considered a naive Bayes model is trained on the this matrices. This data set, whatever has been given here, and this all these values are given. Now you have to calculate if the test point is has label 0. What will be the probability that the point is okay? So you have to calculate what x is what 0 0, right? Given y equals to label 0. How will you calculate this? How generally you calculate this type of problem?
Calculate P1, P1, P2, and other parameters.
So this is a feature 1. This is a feature 2. Okay. So you write what this label is in fix. So label you are fixing, right? And for feature 1, it is 0. If it is 0, what generally you write? 1 minus this one, correct? And for feature 2 also this is 0. Then what will you write? 1 minus. You are going inside this y equals to 0 label and then checking f2. And this should be the value, right, for this problem. Did you know how to write? Like, is this clear, or should I again start? If you have basically
No, sir, it's clear. But what
Basically,
is this?
it is a product of the conditional probability
correct.
for
Yeah, you're just
each of the feature
correct.
given an outcome.
Correct. You're just multiplying like independent of each other, right? So that's why we can multiply directly.
Yeah, because
Okay.
it's yeah, correct.
So you can be asked similar type of problem for any data point has been given, and then you will be asked the probability for that, and the similar type of problem can be there in the exam also. And if you have been asked to calculate this one, how will you calculate this P11? What does that mean? First tell me, any of you, what does that mean? In the first you have to go inside the labeled one, and what you have to check.
Y is equal to 1 and feature 1.
Yeah, for label 1 you have to calculate in how you have to calculate basically the fraction in label 1 of what you have to, which fraction you have to calculate in label 1, where the feature 1 is 1, right? This is what you have to calculate. So if this is what this is label, so go inside this label and check for this feature, the fraction. So out of all those, wherever the label is 1, you have to check the fraction in which the feature 1 is 1. This is what you have to calculate. Is this clear to you?
Yes, sir. But in the question,
If you have understood, any of you can tell me. So go inside that label 1. So how many values are there with label 1? These are the two values, right?
2. Yeah.
Okay. And now you need to check feature 1 is 1. Feature 1 is 1. See, for this example, for x1 feature 1 is 1. For this also feature 2 is 1. Feature 1 is 1 for this second data set also. So that means what? In how many fractions? So in all the cases, wherever the label 1 1, so you have to check what? You have to calculate the fraction in which the feature 1 is 1. So in all the cases, you can see that feature 1 is 1. That means 100%, right? So this is 1.
1. Yes.
Correct? Can you calculate for the other cases? Feature 0 1. Can you calculate this? No, you have to check. Just go inside the y equals to 0. Y equal to 0 you went, and then check for feature 1 is 1. Is that feature 1? No, right? So what should be the fraction? The fraction should be 0.
0.
Correct? Okay, this is how you should calculate. Any question in the exam also. And this will be pretty simple. Don't, if you are using the formula also, that is fine. But you should be knowing what we are calculating. Just go, so whatever the superscript is, just go inside that label and check for that feature and calculate the fraction of that. Let's, for example, you have to calculate, you have to go and check for that first. Sorry, this is incorrect. Go inside the first label and check for the second feature. What should be the value?
0.5.
Again, go inside this label and check for the f2 is what, f2 and how many fraction the f2 is 1. So you can check that f2 is 1 in one of the two cases. So that's why it is 0.5. Is it fine?
Yeah, fine, sir.
So
Fine.
can you explain this again?
Sir,
The last one in feature 1.
sir, I couldn't understand the point. Like, what is this 0.00 transpose? What does the first zero mean?
Okay, which one? This 0.
The third question.
Okay, the third.
Are you able to hear me?
Yeah, I'm able to hear you.
So in the question, it says if a test point has label 0, where y is 0, what will be the probability the point is 0, 0, which means the
See, basically you have to
f1
calculate
is 0, f2 is 0, right?
f1, yeah, f1 is 0 and f2 is also 0. Okay, given y equals to 0, this is what you have to calculate. Okay, and how will you calculate? Can you write it like this? You already know that independence concept, so you can write it like this: f1 equals to 0 given y equals to 0, multiply with product, this f2 is 0 given y equals to 0. Can you write it like this?
Yeah, yes.
Now what you will be writing, f1 is 0. So whenever the f1 is 1, you write it like this, right? 0, 1. And if this feature 1 is 0, that means what? 1 minus this one, correct? Similarly for this case also, because f2 is 0, a1 minus p 0, 2, correct? Is this correct?
It's correct.
Yes, sir.
Did you understand that? How generally solve this problem? Okay.
So,
How will you
sir,
calculate?
am I audible?
Yeah, you're audible.
So then in question it's given y equal to 110 transpose. What that mean?
Okay. So transpose.
Column vectors, right?
Yeah, so that's why we are writing in the form of transpose.
Column vector is represented as a row vector.
Yeah, so then whenever you
Okay.
do that, you mention transpose at the top.
It's like
Because-
even if you are given the data set like this, don't get confused. Simple this one.
Sir, P1 is row 1, P2 is row 2. I like this, sir.
Okay, so don't get confused with this. You can be given with some x as 1, 1. That's it. If this is written like this also, you can't get confused. You can just think of f1 is 1 and f2 is 1. Okay, just the way of representation. And here the x has been given like this. That's why it's given. The data set is in the form of transpose. Okay.
But I hope it should not be there, sir. It creates a lot of confusion.
Yeah,
there are mouthful of notation everywhere. Actually, I'm taking this MLT and MLF both together, and there are so many different. There are different notation everywhere. In MLF, you have different notation. In MLT, you have different notation. It just confuses everything. So I
because
hope.
see,
And
every
beyond that,
faculty uses different.
Yes, but going through the regression in MLF and going through the regression in MLT, it is so confusing regarding this notation wise notation. There are mouthful of notation. It takes hell amount of time to just
understand the
And
notation.
also the confusion is created because lambda in one course is in one class means different thing, and lambda in different class means, and they're all talking about the same thing. End of the day.
Which lambda?
Any lambda. I mean, I'm just using lambda as an example, but
Okay, I
basically
can tell
the
you most.
usage of all these Greek letters and alphabets.
Okay.
So can you please explain 1p2, the example, how it was calculated?
So what clarification?
Just above.
Yeah, which one?
1p2. This one, 0.5.
Okay, this one. See, if this is, so this means what, you have to go to the label 1.
Label 1.
Okay, label 1 and check feature 2 is 1. The fraction in which the feature 2 is 1. So you went to the label 1. So these are the two values, right? Where the label is 1. Okay, this label 1, this label 1. Now you need to check the fraction in which the feature 2 is 1. So this is your feature 2. And what is the fraction? 1 out of 2, right? 1 out of 2 is feature 1, right? 1 out of 2, feature 2 is 1.
Yeah, fraction is 0.5.
So this is what you have to calculate. Okay.
Sir, what is P1, P2? Can you please clarify? I have some confusion.
Which this one?
No, comparing it with the matrix.
It is calculated from the matrix.
This is feature 1, this is feature 1, this is feature 2.
Okay,
this
sir.
is x1, x2, x3.
Okay, sir.
The data set.
Okay, on P, where we are writing this down or numerator?
Okay,
Sorry,
so
is exponent or?
So this superscript is the label 1, and this is the feature.
Okay.
Feature.
Okay, sir.
Sir, would you be sharing this recording, sir?
Yeah, I'll share this recording. Yeah. So, and the next problem is, so I told you this 2 steps. Okay, there is one more thing that you should be knowing how to calculate that. And what is that? That is y equals to, you have been given the data set, like here, it has been mentioned that 0, 1, that's it.
Yeah.
Okay, and then you have been asked what is the probability that will belongs to class 0. How will you calculate this? And this is pretty important. Put it 1000 star.
Bayes law, sir.
Yeah, Bayes law you'll be using, right? Okay, for this method, what should I write? Just tell me. Some of you can tell me, and I'm guarantee if you are just solving this problem, you'll be able to solve in the exam also. So please solve this type of problem. Okay, yeah.
This should be probability of x01 given y is equal to 0.
Equals to x01.
Numerator part you yeah, okay.
Okay, and this what is the numerator part? Probability of
G01 given y is equal to 0.
Okay.
And multiplied by probability of y.
And what is this? Can you tell me what is this?
This is the conditional probability.
Bayes theorem.
This is the conditional probability that given.
This is what we have calculated in the starting, right?
Yeah.
The first equation, right?
Yeah.
So you can calculate this. You can calculate this. You can calculate this. Or maybe I guess for this case now you'll be getting some 0 because some of the cases was getting 0, right?
It will be 0. One of the probability is 0.
Yeah. So how will you write this?
One clarification needed. Where you wrote probability of y equal to 0 given x belongs to 0, 1. Does it mean x is okay? The feature vector, right? So it is feature 1 is 0, feature 2 is 1.
Correct. So just don't get confused with this. I'm writing it again. So if you have been given the matrix in the form of d cross n, what you can do is not get confused, because whenever you see the data points, always you have a thing that the data point is something like this. Feature is written here, and the data point is something written here. This is the normal case that's why many of the people get confused. Okay, because in the seat and all, whenever you will get the data set, it's generally written like this. The feature value will be something like, so you can just whatever in the question is given, you can just write it in this form so that not get confused. 1 0 1 1 and 0 0, and the label you can write it like this. Label is what 1 1 0, and now it will help you. This is the data set that you are getting, and what is the question here? This for this.
Now it's saying y 0 when x is 0.
This is the training data set and test data set you are applying. What is the test data set? Test data set is 0 1. And what should be the label that you have to calculate? Okay, this is what you have to calculate, right?
Yeah.
And you can calculate with the Bayes theorem. And this what is this value? You can just tell me what is this value. I told you in the starting how to write it down. For given y equals to 0, if you have been given the data set as 0 1, how will you what should you write for that case?
P0 0.
No, P x is equal to 0 given y is equal to 0 multiplied by x is equal to 1, y is equal to 0.
Yeah, for that first feature, what you will be writing? P01, and this is 0, that means 1 minus this one, correct? And the second feature is, so this is what, this is P2, correct? Is this correct?
Yeah.
First,
It is, and yes, that's why it's a product.
okay, this product of this, and tell me the value of this. Wherever you go in the label 0, I went to the label 0 and checked for the fraction where the second feature is 1. Is there any value where the fraction, the f2 is 1? There is only one label, right? And you can see that the fraction, is there any value where the feature
No.
2 is 1? No. So that means it should be 0, right?
Yeah, so this whole probability is 0.
This whole probability becomes 0. So this is how you should be calculating if you are getting anything in the exam also. Okay? Is this clear to everyone? How will you solve this type of problem?
So basically it is the intersection probability of the top multiplied by, okay. It's a Bayes theorem basically.
It's Bayes theorem only, and this you'll be getting from the independent. You can just write this probability that we have written in the starting. So like the product of all the probability, because the
So the assumption is that in all the data sets that are given to us in the exam, the features are independent.
Yeah, it's always happened, right?
Class independence.
Yeah, that concept itself. Yeah, correct.
Can you just summarize these steps once again, and I'll just it will revise for us.
Yeah, so I'll just write three things that we went through. The first thing is what if you have been asked to calculate what? If you have been asked to calculate something like this. Y equals to 0, and then you have been given the data set. Okay, any data set. Like for example, this is in the starting 0 transpose. Okay, so how will you be writing? You will be writing in this form: 1 minus P01, 1 minus P02. Okay, this is the first thing. Second thing what can be asked is you will be asked to calculate the fraction part. In the label 1, this is what? Go for label. So I'm just writing it in English so that you'll not get confused. Go for label 1 box. Calculate the fraction in which f1 is 1. So you have to calculate the fraction, don't count it down. If you are counting it also, be divided to the number, whole number, okay, where the label is 1. Okay, and the third step is you can be asked to calculate probability of something y equals to, let's for example, label 0, given the data point x equals to 0, 1. Okay, so these three things, and this you can use Bayes tool, use Bayes theorem to solve this. Okay.
For the prediction, we have to calculate this probability for both 0 and 1 classes, and then which one is greater, accordingly prediction is to be made.
And for the prediction part, you have to calculate both P of y equals to 0 given the data set, and P of y equals to 1 given the data set. And then whichever is, like, let's for example, this is more, then you can say that it will belong to this data set. X test will belong to class 0. And if this X test belongs to first, then you can say this belongs to class 1. Okay.
Thanks. That's.
Sir, could you please tell the distribution of questions for quiz 2, sir?
I told you in the starting, all the 5, 6, 7, 8. This 12.5 marks, all the same. Okay.
Sir, can you just take 8 questions from graded assignment?
Okay. Question number 8. Huh?
Yes.
Okay. And one more thing, question. You were able to solve the question number 6, right? Where you have been given the words and then you have to calculate the probability. That question you'll be able to solve, right? There won't be any issue.
So only apart from Bayesian, there is something else, na Gaussian type of thing in this chapter, in this week. Week 7.
Okay, yeah, that also is there. Yeah, question.
Kernel
Yeah, that
regression, sir.
No, that is the kernel is not in this week.
kernel and all is
You're
there
talking
in
about
sixth.
graded question, right?
No.
Should have asked yesterday. Yeah. So which problem? Question number 8. So sixth is you'll be able to solve, right? I should not be discussing this. Important.
Sir, discuss 6 also, sir, please.
No, it's a Bayes theorem question,
Yeah,
right?
it's not
Sir,
that difficult. It's just the Bayes theorem. You have been given the probability
yeah,
value, and then you have to calculate probability of y equals to, it will
you can
belongs
see.
to spam given the words, okay, or the email. Okay, you can use the same concepts whatever we have used earlier. So you can just use the Bayes theorem to solve this. Okay.
So we would be getting no direct questions from week 1 to 4.
No, there won't be any question. No direct. Yeah, so there can be some concept that will be used, but no direct questions will be there.
The other part, can we discuss about that Gaussian part in this week?
Okay, let's discuss that part also. So yeah. So I guess the question number 8, 9, 10 is from which? 8, 9, 10. I guess the question number 8, 9, 10 is from that concept itself. Okay. So what is the problem here? So you have been given the feature. So yeah. So feature 1 and feature 2 has been given here, and you have been given the label. So all the values is in given 1.5, and this is 1.6, this is 0, 2.1, 2.4, and this is given 1. This is 2.9, 1.5, 1, 1.7, 0.8, 1. 1 second, just take me a break of 2 minutes and then I'll come again. Okay. So let's start with this. Okay. So you have been given the feature value, right? You're able to hear me, right?
Yeah, we are.
Okay. So the label value has been given, the feature has been given, and then the first question is what has been asked to calculate the p. This you can calculate, right? How generally you calculate the value?
I think this is the mean of label.
Yeah,
So it
3
should be
upon 4.
0.75.
Okay. So see what generally happens. So in here, basically you have two classes, right? You have class 1, also class 0 and class 1. Okay. And if you have class 0 and class 1, so both will be having feature 1 and feature 2, right? F1 and F2. And this F1 is also a Gaussian, and this F2 is also a Gaussian. So this basically all the data set is in the form of Gaussian with two feature, right? If this is a two feature, that means it comes under the multivariate with 2 dimension, right? Correct. So whenever you will be calculating mu1, so you'll be having two values, right? Mu1, mu naught for that class 0, mu naught, and for this class you will be having mu1. And this mu naught will be in which dimension? Can somebody tell me? is in which dimension. If you have a data set in the 2 dimension, this mu naught should also be in the 2 dimension, right? So it should be some x. Let's for example, this is the x coordinate and this is the y coordinate. So it should be having x y coordinate both. Again for the mu1 also you should be having x and y coordinate both. Okay, this is how it should be. And again you have been, if you have been asked, the second question is what you have been asked to calculate the mu naught. So if you have been asked to calculate the mu naught, so it should be having two values, the x coordinate and y coordinate. So what should be the mean of x coordinate? Is just add all the values of f1 and divide with the number of terms. So you'll be getting the x coordinate and similarly the y coordinate. So it should be having two values, right? And how will you calculate that? You can, so basically I told you, right? So you can just for this class 1, so first you have to calculate for class 1. For the class 1 you have only one data, right? So what should be the mean? It should be 1.5 and 1.6. Again for mu1, how will you calculate this? There should be x coordinate and y coordinate. So f1 just add it all this 3 for this label divided by 3, and again for this also divided by 3, you will be getting the mu1, right? It is fine to everyone. There is no problem.
And what about sigma square? Sigma is not there in Gaussian.
Sigma is there, but you won't be asked to calculate that.
Okay. Okay.
And if, yeah. Okay. So and maximum, maximum they can ask this all stuffs, and you're aware of this mu1.
Only this calculation is important. Otherwise, the calculation of probability is won't be asked.
There won't be any, because that will be a hectic one to calculate.
Hectic, yes. Well, but
can we look at graded assignment 8, question number 8?
Week 8, right?
Yes, sir.
Week 8.
This is what I told you, right? This week 8, question number 8. This is what?
No, the graded assignment, sir.
Graded assignment. This is not the one.
This is what? This is practice, huh? Okay,
yeah.
This is practice.
This is not even practice. Something else.
No, this is practice, I guess. I'm sorry.
This is practice.
Okay, let's come to the graded assignment question.
That number of parameters part will be there.
When I got the answer, but I wasn't very sure about why I got that answer, sir. I think I was doing something.
Okay, so number of parameters, it's confusing, very confusing to calculate week 8. And this, so see, week 8 calculative question, just focus on the calculation wala question. If you are able to solve this naive Bayes, three types of questions are there. One is you will be asked, you will be given some words or emails or whatever has been given, and then you will be asked to in which label it belongs to. All the probability value will be given. Second similar type of question can be the data set can be given, the label can be given, and then you will be asked 2-3 questions that I told you. The third one is the Gaussian one. The Gaussian one also you'll be given the features set and all, and you can be asked to calculate the mean value or the probability, the simple probability stuffs and all. So these three types of questions you should be practicing. Okay, and these three I discussed. And again, if you have any question, just go and solve those problems. Okay, then come again to the graded assignment. Question number 8.
Yeah.
What is that? Consider a binary classification dataset consists of two features. Okay, so if I have a binary classification, this is having yes, no, because it's a binary, right? And you have two features, F1 and F2. Again, this is having F1, F2. Now the feature 1 is categorical, which can take 3 values. It can take 3 values. So it can take 3 values means I need 2 stuff, right? Because third one can be calculated 1 minus
1 minus, yes.
So 2 parameters from here. What is the second one? The F2 is a numerical that follows a Gaussian. In the Gaussian, how many you generally need? The Gaussian, you need P, you need sigma, and you need mu. Correct? And this P, if you are needing, and similarly here also you will be needing 2. Okay, and here you are needing 1. Correct? So, and the feature 2
So can you please explain?
Yeah, I'm just first. I'll just okay. I have one feature. Feature one can take three values. So we have some two parameter, and that is basically f1 equals to 0 given y equals to 1, and f1 equals to 1 given y equals to 1, and the other one can be done with the
1 minus
subtraction of that. So 2 plus 2. So 1 I'm just taking for that case, and feature 2 is a numerical value, but I'll be needing no. One thing. Why we are needing this p?
We don't need sigma and mu. I mean,
We just need, because it's a Gaussian, right? For the
Yeah.
Gaussian, what generally we need? Mu and sigma. Similarly, for this case also, I'll be needing mu and sigma, right? So this is two things I'm needing here. These two things I'm needing here. 2, 2, 2, 2. So 8 plus 1 I should be needing. 9 I should be needing.
no, 8 only.
So, but
No,
in the
one-
lecture, sir told that sigma, both sigmas are equal.
No. See. Don't get confused. Wait. See, F1 is a feature. F2 is a feature. F2 is a feature. Is in some random values. It's coming from a distribution, normal distribution. So normal distribution. When you are asked to know about the normal distribution, what the value you will estimate? Mu and sigma, right?
Yeah.
So this is a difference for the label. This will be having a different this normal distribution. This is not. Don't get confused with that multivariate that stuff. There both the things are different. So that is a different thing. Here we are dealing with a different thing.
Okay,
See,
so
here,
both the Gaussian that this mu and sigma and the
see
one that
what
told
generally
lecture was
happens
different.
then. See here, there is only one character. Let's for example, this is a x dimension, this is a y dimension. Your y dimension, the y coordinate is coming from some normal distribution. What happens there in that class? So you were having class 0 and class 1, and there f1 f2, and this is combined a normal distribution. Okay, a normal distribution with two feature. So where x coordinate was also normal distribution, y coordinate was also normal distribution, and again for class 1 also you were having two feature, and this is coming from some normal distribution, multivariate normal distribution, where both the dimension was coming from a normal distribution. Okay, here it is just a single dimension, it's coming from a normal distribution. So let's for example, this is so we have dealt with so many normal distribution, right? So this is a x coordinate, and this x coordinate ka value is in the form of normal distribution. There's no y coordinate. There's only one coordinate, x, and that is feature 2. Let's for example, this is feature 2. It's coming from some mu and sigma, and this is feature 2 for class y. So there will be something else for the class 0 also. Correct?
So if I may extend what you just said, so if I'm having a multi-class problem, which is not just yes and no, but let's say 3 classifications, and the same feature sets are there, then it will just be a multiple. It will be 4 times the number of labels, right? Number of distinct labels. The number of parameters I'll have to estimate.
You have to estimate the parameters. You have three
See, we have
labels.
four labels per 4 parameters per label, right?
No, so basically you're dealing with something. So you have 3. So this is
Correct.
basically multi-class. This is
Yeah.
y
So
equals
then
to,
I
let's
will
for
need.
example,
Yeah.
1
Then I'll need
0
to estimate
minus
12
1.
parameters.
Then you have to estimate
No,
more parameters.
14. Yeah, 14.
No, not 14, 12.
So here you have 2.
But for the yeah.
So here you have 2, right?
No, but those are actually coming. I mean, those will be rolled up from the bottom, right?
No. That probability stuff you have to calculate, right? 2 estimated value.
Okay, but the answer is 8 for the 2-1. Then something is
The
wrong.
answer is 8 for this question.
Yeah.
No, sir,
Yeah,
it's 9.
I got the answer as 8, but my logic was wrong.
Shouldn't it be 9, sir? 8
It's
plus
given
1.
as 9, sir.
Yeah, it should be 9, I guess.
It's given as 9? Oh, okay, let me check.
It should be 9, right? See, you have.
No, it's given as 8.
It's given as 8, sir. In the graded
Yeah.
assignment, we have marked 9, but it said wrong.
So they have asked to take the same covariance.
Sir, in
Then we don't
solution
need to
part,
do
they have given
substitutions.
9.
Okay.
Should be
Oh,
9.
sir, there in both MLT and MLF there are so much confusion. Many graded assignment now.
MLF, which question? I don't think so. There is any error in MLF except I guess one question that is regarding the lambda value.
In PCA there are so many confusion.
Confusion. Okay, that is okay. So
We got it resolved right yesterday.
Day
before.
Yeah, they got it resolved, but it's,
yeah. I know you and I were on the same call.
Yeah. But
Sir, in the solution, it is given as 9, but whoever has marked as 9, it says wrong, sir.
Okay, I'll just confirm this.
And we lost 10 marks for.
Okay, I'll check this one. And what MLF? What are the mistake? I don't know. PCA there's one.
In PCA there was one. They say one tutorial tutorial.
Tutorial there is error. Yeah.
There is in tutorial one error is there, and some stuff in graded assignment problem.
Okay, that I have removed
So
the
anyway,
question
coming
itself.
back to this question, the correct answer is 9, right?
For me, it should be 9, but I need to check again if they have given 8. But I think it should be 9. It should be 9 for.
Sir,
Yeah.
so then they have given in the question to take the same sigma value. Then it will only be 8, right? For the feature two, then it will be 8.
Then it can be 8. Maybe you can take the same.
It's
variance
given
for
like
both
that in the
cases.
question. Assume that, take the same covariance for
Oh yes,
feature two.
yes. Correct. So then your sigma is only one value.
Okay.
You don't need to compute sigma for both the branches, only one branch.
Okay. So whatever the question I am seeing there, it's not written. That's why it's like. Okay, leave that, but it's fine.
No, but I think thanks for clarifying the concept. I think that was important.
Okay. Anything else from week 7, 8? Anything?
Thank you, sir. Thank you. It was a wonderful session. You revised everything, and I think now we don't have to revise anything else in this.
Okay,
thank
thanks.
Yes, practice now.
Okay.
Yes, this is.
Sir, one doubt regarding quiz 2, sir. So will there be partial marking for MCQ? As in
MSQ there will be. MCQ there won't be.
Yeah, MSQ means like
Yeah. Partial marking is there.
Like for quiz 1 also it was there, right? But it wasn't mentioned.
Yes, sir. It was not getting added.
What happened?
Bharat.
No, it was there. The partial marking is always there. While sign up, I check for most of last time also I did the sign up. You got the partial marking for well. But if you are doing any mistake, you will not get any marks.
Yeah, got it, sir. Like, thank you.
Yeah, thanks.
Thanks.
Anything? Yeah.
Sir,
Anything you
one
have, you
doubt.
can just ask me. Yeah.
Yes, sir.
Can you solving the practice graded and call would be enough, right?
Yeah, that is enough if you are solving it minutely for all the problem, at least for these 2 weeks.
Okay.
Sir, and will you share this like PDF? One.
Okay, I can see this slide.
Okay.
Okay.
Please share it here,
But
sir.
where will I?
Here only you share it because I don't have access.
It's not like I don't think
So
you'll
one
understand
question.
anything. Yeah.
No, not this one. The previous one.
Yes, sir, notes.
Notes, basically.
This one.
Yes.
Yeah, this. Yeah.
Okay, this here. Okay. What else? Yeah, you are asking something. Somebody is asking.
And recording also, please upload it as early as possible, sir, so we can.
Yeah, now after the session itself, I'll upload it. Okay, so
one
that
question
decision tree
from
that concept got clear, right? If you have the complex tree, it will be overfit, not underfit. Okay, so don't get confused in the paper. Okay.
Okay, sir.
Sir, one
so
question.
many. Yeah. Go ahead.
In Naive Bayes, let's say if they have asked us for some X test, just asking for prediction. then we predict taking both the labels, like p of y
Yeah, yeah.
equal to 1. Yeah, so in that case, we in the lecture sir has told that we ignore the denominator. But
You can
if
because you are comparing, right?
yeah, but if it is like given y is equal to 0, then we should consider the denominator, right?
Given if you have been given the label, what you have to calculate then?
No,
Yeah, means what is the probability? That one question we solved right now. I'm asking about that. I got a bit confused.
If you have to predict something, then you have to calculate probability of y give. Let's for example, this belongs to this given the words or the data set, or you'll be
Yeah,
calculating this. Okay. For this case, there won't be anything that will come on the denominator part. The probability of this stuff will be there. That
x.
you
Yeah.
can skip. Yeah, that you can
Okay.
skip because both the cases will be same, right? That's why we are skipping. We are comparing something, and if the denominator part is same, then we can skip that, right?
Yeah, yeah, yeah. Okay.
Yeah, that is what. And I guess you are asking for this case probability of y given something, and then you have been asked to calculate for the data set, right? For
Ha
that
ha.
you have
Yeah.
some. For that, I told you now. There is like you can just write it in this form, in the form of probability, and then you have to calculate the fraction stuff and all. Let's for example this case. Okay, how will you write this? You have to just check probability if this is 0. Okay, and this is given for the label 0, right? So go write, how will you write probability 0, and the f1 is 0. F1, if f1 is 1, it should be written, you would have written like this, and if it's
Yeah.
0, you write it like this, 1
1
minus
minus.
this.
Yeah. Yeah.
Okay, and similarly for the second word, like second feature also, and whatever the number of feature, mostly you'll be given 2 or 3 features in the examples. Okay.
Okay, sir. Yes. Thank you.
Any other doubt you have?
Sir, can you once generalize that what are the number of feature for the independent one, and what are the number of
No,
parameters for dependent?
no, that is difficult. Like every time, if you are getting some different type
Because
of
every time for
stuff,
the different question I saw, and different I sort of formula I saw on the Discord, so it is getting confusing.
there is no formula as such. That's why everybody is writing their own formula.
No, like Karthik sir once write like something like that, k into d plus k to the k into m plus 1, something
Okay.
like that.
Okay. So whatever
Oh,
he would have written correct, I guess, because.
okay.
But I don't have that formula. Yeah, Karthik would have, but I don't know about the other people.
Sir, shall I say that formula, sir?
Yeah, you can say that formula, but the
No,
okay.
but
So what is that?
I have problem in understanding in that formula, actually, not about that formula.
Okay. So it's better to go with the whatever has been written now. Just go with that flow. I guess you'll be able to calculate the number. The formula will again. I don't know formula that because
Sir,
every
if
time.
the
See
data
for this
set is
case now,
long, then it will be harder to find, no? Like without formula.
but nobody will ask you for that bigger data set and all. They'll be asking you
Okay.
for okay, binary classification. Two features are there, three features are there, one feature is having all. See, and the formula, I don't know how will that work because every time I can give you some different, what you can say things like f1 can be a binary, f2 can be
Yeah.
some categorical value with four feature. Then it will be
Right.
difficult for you, I guess. It's better to the starting
Manually count it.
count it because the numbers won't be that high.
Sir, I pasted one question in the chart. Can you please explain?
And it's not important for the paper also. You can just skip that
Okay. Yeah.
if you're
Thank you,
having
sir.
some.
So can you explain the question in charts?
One second. There are so many questions, huh?
Yeah.
Okay, let me go through that one by one.
Sir, can we ask some question from PYQ as well?
Yeah, yeah, you can ask, but like already we are late. Okay, you can ask, but I'll just try to.
If it is too much, then I can post it on there.
Mm-hmm. Okay, okay. So
Sir,
what's the? Yeah.
sir, I posted a question in chat. Can you please answer that? Explain.
So for the Gaussian naive Bayes, what are the that parameter that you need? Tell me that. What are the parameter that should be needing for the Gaussian naive Bayes? What are the parameter that you generally estimate? Hmm? Hello.
Sir, that was a
Yeah.
confusion for me, so I don't have clarity on it. So,
Okay, so the first thing that you should be calculating, if it's a binary, then you should be calculating a probability value that it should go with label 1 or label 0. So that is the one thing. Okay. The other thing is what? If you have this is a Gaussian, okay, and so there will be if this is two class, that means both the classes will be having a mean value, right? So mu 0 and mu 1, correct? And if you are taking the sigma or whatever the variance, same variance for both the cases, then you have four parameter that you should be needing. And if you are having a different, then you should be having five parameter that you should be estimating. Okay, and that sigma thing that will depend upon the decision boundary. What is the decision boundary? If this is linear, then it is same, and if it's not linear in the form of quadratic, then the sigma is different for both the cases. Okay.
got it. So, two mean, two
Yeah.
variance, four
Two, not two,
parameters.
four. I told, right?
Yeah,
Four,
yeah, four
four.
parameters, and that two.
Correct. 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 Yeah. Anything else from
So
anyone?
question number 13 in mock. I think the answer that they have given in the written and written mocks are incorrect.
Okay, that I'll check and will maybe I'll post it in the discourse. Okay.
Sir, any topics from week 5 and 6, sir?
The QP, that quiz paper, I haven't went through the week 5 and 6, but you can just go through the solve the practice and graded assignments questions. And maybe previous term, if you are solving, I told you, go for the previous term paper, last term, previous term paper, and that January term paper. Solve that January term and the previous, like 22 September term. Solve both the term from week 5 and 6, and I don't think so there will be any issue in solving the problem. Okay, go and write the solve the at least for this 2 week I told you 7 8. Go and solve whole paper of quiz 2 of September term and January term. That, and if you're able to solve today, if you have only MLT, if you have other subject also, then it will be difficult for you. But if you have time, that is not like, yeah, tomorrow only you have paper. Just go through that with the question. If you are able to see that, okay, I'm able to solve that, skip that. If you're not, just solve that. Okay, and if you want the solution, we can provide the solution for those. I guess TS has already discussed the solution for the previous term paper. If you are facing any issue, you can just go and see that. If you want the solution also, that solution can be uploaded, and it's uploaded already, right, on the I guess portal. Just solve that. At least if you are not having to solve practice and graded, solve the previous term paper at least once. And this I told you in the quiz one also. At least solve that. If you solve this, I'm pretty sure you'll get some advantage of 10-15 marks.
Okay, sir.
Okay. So if you don't have any further doubt, we can close this, right? After this, I'll upload the solution also.
Yes. So,
Thank you so
I have
much, sir.
notes.
Yeah. Thanks. Yeah.
Thank you so much.
Go ahead.
Thank you, sir.
Sir, please
And
upload notes as well, sir.
okay. And any doubt, you can just mail me. Okay. Till maybe tomorrow you have session before that exam also. You can just mail me.
Sure, sir.
Okay. Okay, then all the best for your paper and goodbye.
Thank you, sir.
Thanks everyone.